Hello everyone, welcome to my YouTube channel. I am Shalaka Deshpande. So our today's topic is architecture of 8051. Now, why we are studying the architecture? Before directly jumping to programming of a 8051 microcontroller, you should be having general idea about its architecture so that you become efficient programmer. For example, if you want to construct a building, the architecture and planning is important before starting construction directly. So similarly, the architecture, understanding of the any processor's architecture is important before directly jumping to its programming. Correct? So without wasting much time, let's get started with the architecture of 8051. But before starting, let me tell you, I'm going to give you a general idea about the architecture. This is the part 1 of the video, and as we will proceed in this video series, I will make the part 2 of architecture, part 3, part 4, and in that I will give you the detailed architecture. So in today's lecture, I'm going to tell you about the important units of the 8051 microcontroller which you should know, which are the important part of architecture. I will give you the generalized idea about the architecture in this first video. Okay, so let's get started. So see, this is the diagram of 8051 architecture. 8051 architecture consists of port 0, port 2, port 3, port 1, latches and drivers. For every port there are drivers and there are latches. Okay, clear? Fine. Then it consists of the data memory, program memory, RAM and ROM. Okay. Then it consists of the interrupt controller, then CPU, timing and control unit, oscillator unit. Then here we have timer 1, timer 0, UART for serial communication. We can see there are two pins, TXD and RXD. Okay. So now the first and important part of this architecture is the CPU, central processing unit. It is also called as the brain of your microcontroller. Okay. So 8051 microcontroller, there are ALU, arithmetic logic unit. Okay, arithmetic logic unit performs arithmetic and logical operations. Okay, fine. It performs arithmetic operations like addition, subtraction, multiplication, division. Okay, and it performs logical operations like AND, OR, NOT, XOR. Okay, so these are the arithmetic and logical operations performed by the ALU. Okay, so see, now consider the example. Now there are two numbers, 4 and 5. So these two numbers I want to add. So before adding, the result of that, whatever will be the result of the arithmetic operation which is performed by ALU, that result will be stored in the special register. And the name of that special register is accumulator. For example, I want to add 4 and 5. Suppose 4 is stored in accumulator. It has to be stored in accumulator. One data has to be stored in accumulator. Then 5 is stored in B register. Okay. And then there is the addition operation, 4 plus 5, addition is performed, result is 9 and that 9 is again stored in the accumulator register. Okay, clear? Fine. So in this way, the arithmetic logic unit performs arithmetic and logical operations in the 8051. Now there is one more Boolean processor which is integrated inside 8051 microcontroller. That is, it performs bit manipulation operation. Now what is this bit manipulation operation? Set bit to 1, suppose the bit is 0, set bit to 1, clear bit, suppose the bit is 1, clear it to 0. Okay, set bit and clear bit operation, these are the operations which come under bit manipulation. Then there is one more operation called as a complement. Okay, complement operation, it complements, it turns 1 into zeros and zeros into 1. So the complement, set bit and clear bit, these operations, they are performed by Boolean processor. Now where is the result of these operations which are performed by Boolean processor stored? Now there is one carry flag inside the 8051 microcontroller. Now where is carry flag? What is function of carry flag? We will discuss under the section registers in 8051. Currently you just remember there is one carry flag inside the 8051 microcontroller, and result of these operations, that is your bit set, bit clear, complement bit, bitwise OR, bitwise AND. The result of all the bit manipulation operation, they are stored in the carry flag. Carry flag act as an accumulator in your Boolean processor. Okay, clear till here? Fine. Now the next part of this architecture is the memory. Okay, now there are two types of memory in the 8051. First is the program memory and other is the data memory. Now let's see. Program memory is ROM. ROM is a 4K bytes. Okay. And data memory or working memory is a RAM. RAM is 128 bytes. Okay. Fine. Now here inside the ROM there is a code. Now whatever the code or functionality which you want 8051 to do, that code is uploaded inside the ROM, read only memory or EEPROM. EEPROM can also be there, but the code which has to be uploaded in any microcontroller, that code is uploaded in the ROM. Okay, clear? Fine. Now there is one more 128 bytes of RAM called as a special function register, and this RAM, which is of 128 bytes, holds all the data which is necessary for operation of a program. Whenever the program is executing, it needs the data, it needs to access the data and do operations on that data, and that data is stored in the RAM. Okay, fine. And then we have special function register, that is also part of RAM. It is 128 bytes. Now what does the special function register do? What are the registers which come under it? It occupies 128 bytes of memory inside the microcontroller. Now see, these special functions are accumulator register, then PCON, SCON, TCON, timer register. Various registers are there which we are going to see it in detail as we move ahead. But now you remember that the interrupt controller, timing and control unit and serial port UART, these three peripherals, the control and operation of these three peripherals and their status is stored in SFR, special function register. Suppose 8051 performs a particular function. Okay, the controlling of that function and status after performance of any function, means after completing a particular task, the status of that task or a function is stored inside the special function register. So it basically controls the operations of 8051, and it stores the status after the operation of 8051 is done. Whatever will be the status, that status is stored in the special function register. Okay, clear? Fine. Now see, there is one more thing in the memory access. Now there are two types of memories, internal memory and external memory. Whenever I want to access internal memory, the internal memory access is fast, and if you want to if you have more number of data and you require external memory and you want to access data from external memory access is slow. Now let's see why. Suppose I want to access one external memory. Now how much external memory a microcontroller can interface? Okay, that depends on the length of your address bus. For example, if address bus is 8 bits, 2⁸ KB of external memory can be accessed. If address bus is 16 bit, then 2⁻16 kilobytes of the external memory can be addressed. So the length of address bus is an important factor in deciding how much external memory we can interface to the microcontroller 8051. Okay, fine. Now these are the ports, port 0 and port 2. Okay, port 0 holds the lower bit address and port 2 holds the higher address. Okay, port 0 is address bus and port 2 is address data multiplex bus. And these port 0 and port 2 are used to interface external memory to the microcontroller 8051. Okay, clear? Fine. Now the external memory access, why it is slow? Can you see this port 2? This port 2 is a multiplexed bus, data address multiplex bus, means it can carry data and it can also carry address. Same lines are used to carry data and address both. And because of this reason, the external memory access is slower compared to internal memory access. Internal memory, if you want to access it, is fast. External memory is slow. Now, and one more thing about memory, there are two types, aligned and non-aligned. Suppose I want to access or load into the processor 4 bytes of data. Okay, so I need a memory location which is a multiple of a 4 byte. I have to access it from the memory location which has to be multiple of the 4 bytes. That is aligned, and the operation is fast in case of aligned memory architecture. And if it is non-aligned, means suppose I want to store 8 byte of data, and the memory location is not the multiple of a 8 byte. Okay, I mean to say, for example, it is not a multiple. It can be other than that. It can be any 756 or any number KB, and that memory is not a multiple of 8, then it is non-aligned memory access. Okay, and that is a slow. Aligned is fast, non-aligned is slow. And in the ROM and RAM, there are various locations, and those locations are having addresses. Why they are having addresses? Because processor should know, or controller, in our case 8051 microcontroller, should know which location to access. Okay, how it will know? So every location inside the memory is provided an address. Okay, clear? Fine. So this was about the memory. Now let's see timing and control unit. See, in 8051 microcontroller, if it wants to communicate with external devices, then it requires various signals. Various signals need to be generated, and those signals are generated by timing and control unit. Timing and control units generate signals like address latch enable, ALE, PSEN bar, program strobe, then it generates read bar, write bar. Okay, so these are the signals which are necessary for accessing the external devices. Okay, clear? Fine. So to access the external device, this timing and control unit plays a very important role. Now the next most important part of the 8051 architecture is oscillator unit. As I already discussed in my previous lecture, oscillator unit provides a clock signal to all the blocks of the 8051 microcontroller. Okay. Now this oscillator unit is having external crystal to generate the clock pulses, and the oscillator circuitry is internal. Externally, a crystal is connected to function as an oscillator. Okay, fine. Now the oscillator frequency depends on the device depends on the frequency at which a device operates. For example, this 8051 operates at a 12 MHz clock frequency, so it will produce 11.0592 MHz frequency. So why it is why it is a bit lesser than 12 MHz, right? See, because in the serial communication, the baud rate has to be 9600, and the other devices are compatible with slightly lower frequency than 12 MHz. So the oscillator generates either 12 MHz or a bit lesser than 12 MHz frequency. Okay, so this is about the oscillator unit, and I hope you have understood you have got general idea about the architecture of 8051 microcontroller. We are going to discuss it in detail as we will move ahead. I will discuss each block in detail as we will move ahead. For now, I hope you have got a general idea how the architecture is and what are the important parts of architecture. We will also cover the register organization. So I hope you like the video, and I conclude my lecture. Please like, share and subscribe my channel. Thank you. Bye-bye.